Welcome back. In this video, we're going to go through the Llamafile repository. We're going to clone it to the system, and we're going to build the tools from it using Make. So to get into it, I feel like we need to do a breakneck speed crash course on Make, just so that you understand what you're doing when you run the Make command. I feel like it's pretty important to have some idea of what in the world you're doing, and I'm going to give ChatGPT credit for the assist here on making super easy orchestrating the content for this very, very fast crash course, or just a speedy overview on Make. Make, it's a build automation tool that you run in the command line. It takes the heavy lifting out of the very monotonous steps to build. It manages the dependencies and all that, and thus it speeds up development because it can take out of your hands dozens or sometimes hundreds or thousands of individual processes. Technically, I think it's pretty much used for C and C++, but you can technically use it for a lot of other things. It works with any languages. It's cross-platform. If you don't have it on your system, sudo apt install. You know, again, we're on Ubuntu here, which uses apt. It's built on Debian. But you can, if you don't have it for some reason, and in Linux, it's just called Make, but it's technically Gmake, GNU Make, as opposed to Make from the BSD operating systems. But at any rate, sudo apt make install, or if you have brew, brew install make. Sorry, sudo apt install make. And if you have brew, it's just brew install make. And if you're on Windows, you can do this msys2 or Chocolatey. Those are kind of package manager. Well, Chocolatey I think is like a package manager, if I understand it correctly. I'm not on Windows a lot. And this msys2, if I'm pronouncing that right, when you install that, whatever it is, an environment or something like that, and I believe you can run like Pac-Man from Arch. It allows you to run the Pac-Man package manager. After you try and install it, you always want to just run whatever it is -- version. In this case, it's Make, and that just tells you real quick if you have it installed and correctly. If it responds to that, generally you know that it was a success. And the basic structure, very, very simple. It gets wicked complex, as you'll see in the Llamafile repo, but the basic structure is straightforward. There's a target, there's dependencies, and there's a recipe, right? The hello is the target, hello.c is a dependency, and then the recipe is the commands that you have Make run. In this case, you're compiling with the GCC compiler. This is just an example of a very, very wicked simple Makefile. And this one uses a variable, cc equals gcc, and that's so that you can, on the fly, you can very easily, through long Makefile scripts, you can change out the compiler, and then you use the variable just with a $sign in parentheses. Nothing complex there, although it gets complex. So what Make can do when you have a repo that you're working with, it rebuilds when you run the Make command. If there's changes, it'll rebuild those things that need to be rebuilt. And if there are no changes when you run the Make command, it won't do anything if there's no changes anywhere in the repo. So if you were to do something as simple as touching a file to update the mod time, even though you didn't technically make a change, but Make will sense a change in that modification date and it'll rebuild, because I'm pretty sure that's how it detects changes. It's not going to parse your code and see if you changed a character. It's going to look at the mod times or the modification dates. Pretty sure it's how that works. I've never used Make in the BSD platforms. I believe that the Make for BSD, see, when you run GNU Make, which is just Make on Linux, if you run that on a BSD platform or operating system, I believe you have to call it Gmake to differentiate from their version of Make. And I don't think the BSD version of Make has these functions built in, like where you can run a shell command using Make if you put this into a Makefile, the wildcards and converting file types, stuff like that. Could be wrong there, but I'm pretty sure that the BSD version of Make doesn't have those capabilities. So I'm sure someone will correct me if I'm wrong, but the GNU Make has these extra capabilities, baked in. And although you can use Make for a ton of other languages, pretty much anything you want, I would say. Not that I've done it. Maybe I have a couple times, but it's not a regular thing. But it is primarily, if you were just to look at the statistics of it, I guess, it's pretty much used for C and C++ languages for the most part. But, like it says, you can use it for nearly any language. Rust has cargo, but you could still, if you wanted to automate the build and for some reason or for someone else, Python, doing PyInstaller or making standalone executables, things like that, you can use Make, build Make files and use Make to build it, just to automate those things. things. And I guess that would be pretty helpful, I guess, if you were rebuilding things a lot after, constant changes. And then you can't remember if you've made a change or if you have a bunch of other people contributing to a project, say on GitHub or at work, if your job entails these sorts of things. If you just couldn't remember, or you were in a hurry and you wanted to just see if there was changes, and if there was, you wanted to build it, you run make, and if there wasn't a change, it wouldn't rebuild. So it's kind of nice in that way, I guess, if that's what your life or your daily grind entails. And this just goes over real quick the difference between make, Gmake and Cmake. Cmake, I think, it's a meta build. It generates make files, and then make uses them to build projects. And right here, Gmake, it's another name for what us Linux guys call make, mainly used on the BSD systems. I should look this up before I keep talking about things, but BSD, I think, is the Berkeley software distribution from, building out, forking from something a long time ago, probably Unix or something like that, or old Unix POSIX something or other. And so on to the make build system. This is all pretty straightforward, just kind of reiterating it in a conversation, where to install it again, just to make clear. And then if you install this MySys2, again, I apologize if I'm not pronouncing that correctly, because I don't go on Windows, and maybe I should get reacquainted with it. There's a lot of things I should do, I guess. It appears that it allows you to use Pacman, the Arch package manager, and Chocolatey, which, to be honest with you, I've never been into it, but I've known about Chocolatey, basically acting as a package manager so that Windows can kind of keep up with what Linux is doing. This kind of just describes better the target, the format of a very stupid, simple make file. You have the target, the dependencies, and then the recipe. Again, very, very, very simple. I apologize if I'm annoying in the sense that I generally like to do very quickly, go through something twice. I feel like it helps things stick, because when you're moving this fast through something, if you just see it flash in front of your eyes twice, you're better able to keep the gist of it. And that's all we really want. I'm not trying to teach anyone to use make. To be honest with you, I hardly use it. I just want to give you an idea of what you're doing when you run make, when we go after this to build the Llamafile repo. It's just a good practice in any area of life or industry to have an idea of what's happening when you press a button, so to speak, on anything, a machine, computer, or in a car. If you're pressing buttons, you don't know what in the world you're doing. It can have some funny results, I guess. This is just, like I said, we covered earlier, running variables. And it does. I guess make checks the timestamps. So if you were to run the touch command and touch a file, not actually change it, but just touch it and update the mod time or the modification date, that's what make recognizes explicitly, I guess. Yeah, right here, if you run the touch command, updating timestamps, then make will rebuild. So if anything at all in the repo has changed, and I think that's dependencies or whatever, maybe it's any file at all, but usually if you're changing something, it's going to need to be rebuilt. I don't know if it would rebuild if you just change a character in a README or anything. Never done such a simple test. We're getting into some deeper stuff, so I'm going to gloss over this. If you want to know more about this, there's tools at your disposal like there never has been before in the history of mankind. Just throwing together this little stupid simple slideshow 2 years ago would have taken a couple days, and I did it in 5 minutes or less now. We're living in a new age, and I don't think many people have really realized that yet. This is just about rules, wildcards. These are things that I think differentiate Gmake from the BSD version of make. We don't really need to know these to run the make command. Multi-file project. This does apply to the Llamafile build that we're gonna do. It does apply for sure. You're gonna see some crazy stuff when I do a dry run. It boggles my eyes and my mind, how much stuff gets run all at once, because it doesn't look like that big a repo, and then when you run it, and this thing doesn't look big at all. But boy, you run it and you're gonna see something. And this is using object files. If you're interested, go ahead and dive in. It's just compiling, basically making a list of all these dependencies, saving it into object, and then using it with the $ parentheses as a variable. When you really just take a few moments and just mentally, before even asking ChatGPT or Claude or whatever, just see take a look at what's going on, and you can intuit quite a bit of it. The parallel builds, this is something I think we're actually probably going to use when we build from the Llamafile repo here in a little bit. The J4, it's just telling you to run multiple things concurrently. And then we're probably not going to run the D or trace flags, because they end up doing a lot of extra things that we don't have the time for, really. I believe it pulls down and compiles like a Cosmos zip file, and the trace is a bunch of dependencies and things like that. It takes a while to watch all of that, and it's not necessary. We're going to run the make with the N flag that'll just show real quick a top level view of everything that's going to be executed. So again, this is just environment variables, what makes make what makes make unique from other things, and how you can use like using the CC variable, you know, the compiler variable, so that on the fly at the top level you can swap out GCC for Clang, you know, things like that. And here, I guess portable make files, I think what it means here, okay, right down here, detect. I was just going to say, I think this is detecting your OS and then running the appropriate command, because rm-f is a Linux or Unix thing, and delete/f is, pretty sure, is a Windows thing, and that's exactly what it is. So once it detects your operating system, so that's where using a make file instead of a bash script or a PowerShell script, this is where build once, run twice, or run anywhere type of thing. If you set it up appropriately, you can build it once in a make file because it's cross-platform, which is really what the Llamafile is all about, with what Justine Tunney did, in a deeper way than make files are cross-platform, really. We'll go into that at a future point. This is just an interesting facet of make, or Gmake, because you can take care of many different scenarios or eventualities depending on who's going to be running your make script or your make files in your repo or whatever project you're doing, and whatever system they're on. You can account for a lot of those variables in one make file. It's pretty cool that way, and it's been around like this for a while, I believe. And right here, we're not going to run the D or the trace. We're going to run the N and see kind of a top view of what would happen and what will happen. And this is where, okay, right here, replacing bash scripts with make files. You know, I was thinking in terms of building and installing projects, but also if you're using outside of C or C++, when you build a pretty sophisticated Python project, you want to test it. One of the more commonly used ways to test Python projects is with PyTest. With this, you know, so you see the test colon down here, the clean colon. Those are, I think they're called rules. And so at the command line, if you have these rules in your make file and you're in the directory with said make file, and you then with these rules in here, test and clean, you could run in the command line make space test. And that sort of second command or argument or parameter for make of either test or clean that you can run in the command line, those are valid if you have the rule and use it in the make file. If you didn't have a body here of test and then running PyTest tests, and then if you didn't have that rule or that recipe there, then if you ran make space test in the command line, it would kick an error because you don't have a test rule with a recipe in the make file. That's pretty straightforward, you know. I always cover things as I think of them, and there's probably more logical ways in the way my brain works. The difference between Gmake and the BSD make is just outlining hopefully what I told you. Hopefully I was telling you the truth. So yeah, it's just the difference between make on Linux and make on BSD systems. Pretty straightforward. It sucks that you have the same word for so many things, and like in this series here on Llamafile, it can be challenging because I talk about a Llamafile, and then there's the executable Llamafile command that is not a .Llamafile, and I'm constantly trying to make sure that I'm using my words correctly and making the context of whatever I'm talking about correct. And so I try to use, in real life, I don't say .Llamafile like hardly at all, but when I'm trying to explain Llamafiles, like the standalone server and everything built in, or on a video like this, I try to remember to say .Llamafile so as to differentiate it from the Llamafile executable command that does not have a model or an LLM or any model of any sort zip aligned with it. These common terms that are so close together in context, it makes it pretty challenging. You know, it would be nice if they just named them something different enough, just a different word that means that, you know, like make and then build, if build's not used for other things already. It would be nice, but, you know, I don't make the rules. This just goes, okay, so BSD make does not have these built-in functions like the shell, running shell commands in a make file, the wildcards, and this, I believe, is just converting file types maybe, and just the syntax difference, I guess it goes over beyond that. And then, so that's make in a nutshell. Explain it to me like I'm 5 years old. This is your cursory understanding of make. This tells you enough to run the make command. By no means makes you an expert. What I just went through doesn't even make you a novice in understanding a make, but it gives you a very quick background and context for what in the world, for the button you're about to press, which is running the make command, right? That's all I was trying to do. I hope that was clear. I think that's pretty clear to me. I hope that was clear enough to make you confident and not just feel totally ignorant about what we're about to do or what you're about to do on your own system if you follow along. So back into the GitHub repo, what we want to do on a file system, now you can put it wherever you want, it's your system, right? But generally speaking, when I'm cloning repos down to my system from GitHub or anywhere else, but usually almost always GitHub, you can create a directory off your user home directory. Most often I've seen it just src for source. I put in source code just so it stands out to my eyes, especially when I'm zipping around in Ranger through my file system or even at the command line. The source code stands out to me a lot better than src, right? Like that stands out to me a lot better than that does. But whatever is your druther doesn't really matter. And you don't even have to organize your file system like this if you don't want to. I picked it up from someone smarter than myself. It's not like you're taking my word for it. Pretty much everyone is smarter than me that I'm around. I'm just going to remove that real quick. So if we go into the source code directory, clear the screen, and here I'm just organizing by broad sweeping categories: AI graphics, miscellaneous. This is easier to look at if I go into Ranger. I clone the fabric repo. You've probably heard me talk about that. The Llamafile repo, the Llamafile rag example repo. Under AI graphics, not that I know a lot about or even really care about generating graphics. I'm trying to spend a little bit of time learning about it. Probably take me a couple weeks and be able to use most of those repos. In miscellaneous, you can sudo apt install these things. The DuckDuckGoer, the DDGR, and Googler, they're just command line search tools, and I build them from source sometimes. I generally keep the version on my system, I keep updated through apt or Nala, which is just a front end for apt, so that it just updates as I update the system. But I do clone the repos down most often just to see what's inside of them and to understand how they work. But enough of that. So under the AI category, like a broad sweeping category, we go in and here's the Llamafile. And just to demonstrate this better, we'll drop out into the command line and we're gonna burn that with, always use this one carefully. Don't be as cavalier as I'm being, but remove recursive, R for recursive, F for force. It's just gonna wipe out the Llamafile repo that I cloned down to the system here so that we start at the same step here. So to clone the repo down, I'm going to clone the Llamafile repo down to my source code AI directory. And so you just gotta, if you want to do this the newbie way, and believe me, I might as well be a newbie compared to a lot of people. I always kind of cringe at the thought of a real Einstein of this stuff watching one of these videos. I'm trying to do it for people that know less than me, and boy, there's probably some people rolling their eyes at me with some of the stuff I do. But so we'll just do git, and you got to have git installed. If you don't have git installed and you're on Ubuntu, it's just sudo apt install git. Or if you're smart, you'll upgrade to Nala. You'll sudo apt install Nala and do sudo Nala install git. Pull that down to your system so that you can do this, which is git clone, and then you go and grab this URL and paste it in. Now I know that there's a lot of people that it's probably from bygone days, because I remember using it, but they put a .git on the end. If you're going from GitHub, you don't need to do that anymore. Really, they just, as with all things, trying to make it easier and faster, less stuff to type is always better. As long as you can accomplish the same thing in a clear fashion, it's always better. Now, you'd still, mind you got to use .git if you're cloning down from other remote repositories that are not GitHub. I'm pretty sure that if you're cloning down remote repos that aren't GitHub, like all of them, you got to use .git, I think. Like if you're on GitLab, I think it is. And I don't know about GitLab, maybe not. But if you have your own remote repositories, generally you're going to put .git on the end of this, but we don't need to with GitHub, so I'm getting that. So sorry about that. We'll move on. So here we just press enter, git clone the URL, and we send, and you can see it doesn't take long. And now we have the Llamafile repo clone right back down to our system. Easy peasy, right? So we go into the Llamafile repo, clear our screen, and you see this is what I like about cloning repos down, even if I'm not going to build or run anything from it. The look of this compared to this, there's hidden things I can do the LLA with the way I have easy alias, and it'll show all the dot files, whether or not you need them. But the reason I like this, because over here, you're clicking on things and pressing back, and you have all this other stuff, when really, if you want to know what is in here and traverse it with all your normal tools, clone the repo down, and then you can just, in your terminal, or with Ranger, or whatever you like as a file system navigator, and you can traverse, and you can go through this thing, and we can go through it at the command line. I like to use Ranger, I keep doing FS. If you haven't seen me in the past, the FS is just a mnemonic alias for file system. If I want to jump in and zip around my file system, I use Ranger. So if Ranger's the command, I alias it to FS. So looking at this repo now that it's down on our system, you start to see really fast and much faster to look at the entire thing in something like Ranger down on your system than trying to click through back and forth. And yes, when you click through something, I understand completely that you can get this side tree. This still to me is not, it's not the same. To me, it's not as easy. I can't use my normal tools to zip around and traverse it and all that good stuff. So at any rate, you start to see, like under Llama CPP, under this directory, you see, iMatrix, the Llama Bench, Lava, Perplexity, Quantize Server. These are actually going to be some of the tools that are going to be built into our system. We could spend forever parsing this repo. That's not what we just want to get in here. And it has one tiny Llama model already integrated, the stable diffusion, some third-party stuff. Here's the Makefile. So we have the README, which is basically this. All this stuff that you can read here, that's what the README is. And then you have the release MD. And this just gives you some further notes. If you're going to build your own Llama files, this has just a bunch of things you need to know, helping you visualize the structure of what it is you're going to be building, how to properly build one if you're going to distribute it. Here, if you visited this repo in the past, you'll see that there's something fairly new, this local score that's been added in at least semi-recently, and that has a lot to do with some public scoreboard where you can document and just post results from whatever your particular system is, and it collects that data as anonymously as possible. If you're going to tinfoil hat your life, you're not going to do things like this, but it's useful for other people to know these things. It really, really is. The CIA, I don't think they really care about your system's hardware, but at any rate, that's just a quick overview. And so what we're going to do is we're going to build, right? That's what we want to do. If we go in, let's take a look real quick again at what's in the Makefile. This is what's going to happen. And these are the other Makefiles, build Makefiles, all that. And these are buried in some of the other directories. So what happens basically is that this Makefile, in the process of doing anything, it's calling other Makefiles, which are going to automate other processes, some of which might call other Makefiles. You'll see real quick, this is not what I would call a stupid, simple Makefile here, right? I don't expect you to fully understand what's going on. It would take me a little bit to really sit down and explain to you. This Makefile is not stupid sophisticated, but it's just enough that it's exhausting to look at, right? It is for me, and I can pretty much could walk you through and tell you everything that's happening in here. Not like a professional or anything, but it's at least less scary once you get someone to show you at least a scratch the surface overview of what Make is, what it does, like we did at the beginning of this video. All of a sudden, this is a lot less scary, right? If you didn't have any idea what the make command was or what it did or what a Makefile was, and then you looked at this, you'd be like, oh boy, here we go. I have no idea what I'm about to do. And with just that quick overview, this is a heck of a lot less intimidating and scary. We'll back out of that. And so that's just a quick glance into the Makefile. If we want to try and run something here, let me make sure that I have a previous build that I did. I want to make sure that I have all that cleaned out of my system's path. So over coming from the user home directory in .local and up in bin, I just moved over to storage. From Llamafile on down, all this stuff. These are executables made from running the make command in the Llamafile repo. And you can see here the local score is not included. That's a newer version of the Llamafile repo than I built previously. And so I just moved all those things into cold storage from the .local bin directory that's in my system's path. And then there's also there's some man pages and help files that was built that are probably gonna, let's see, yeah, man, yep, all right, here they are. So this, I'm just gonna rename this real quick, just so nothing interferes with anything else. So in Llamafile tools, this is the same thing. I just add the dot back. A lot of people use use .bak for indicating that something's a backup, and it also adding .back. It just gets out of the way. It's technically a different name, you know, so it's something you can do real quick. And with Ranger, the key bindings, CW for change word in Vim, that's the key binding, and then you can rename something in Ranger that way, and that's just a pretty cool thing, I think. I like that a lot. So going to source code, back to our Llamafile repo that we've cloned down. Let's take a look real quick at the README. If we go down, J8 they use. So, okay, here's another thing that I didn't bring up, and apparently I didn't talk about it with ChatGPT. The sudo make install. That's if you want all these tools that we're about to build. If you remember just from a few moments ago, we had all those tools built, and I had them inserted into .local bin. This is where I had them all, and I took them all and moved them into storage, right, into cold storage. That's because I kept the build local to the local user. If you use make install, if you were to type in sudo make install and this prefix equals /usr/local, that's because the slash being the root directory, you know, bedrock for a Linux system. I call it the slash directory. I might be the only person on earth that calls it the slash directory, but I call it the slash directory so as to differentiate it from /root. That's called the root directory because it's the root user's directory, and then the slash directory is also called your root directory. You know, just like the home directory is often referred to in the exact same fashion, called the home directory, and the user's home directory, because you have /home, which is technically your home directory, a home directory, and then /home/ whatever your username is the user's home directory, and a lot of people say your home directory. This sort of word redundancy and context that are not just close together, they're on top of each other. You know, I've always hated that. And so like I said, I might be the only person on earth that calls your root directory meaning bedrock, meaning just slash. I call it the slash directory. I'm not trying to be cool or stand out on my own. I'm just trying to differentiate it from the root directory, trying to differentiate the root directory from the root directory, right? Oh God, I hate it. So at any rate, I'm sorry. So if you use sudo make install, what you're going to be doing is when you build from the Llamafile repo, the tools that get built from it, if you want them inserted globally, meaning for all users, all login users on your computer system, if you want them all to have the access to the same tools that you build and they all stay updated the same, then you want to install, after building, you want to install these things in your deeper file system. Real quick, what I mean by deeper file system, and the only reason I'm going into this and spending all this time is because we're not often going to be learning things like this, you know, learning to use make and things like that. But if you go back, say we're at the user's home directory right here, right? So this is your user's home directory as opposed to the home directory, which is one directory back because it's literally called home, as you can see right here. So this is the home directory, and forward one, once you pick a username and you go forward, this is the user's home directory. You know, the home directory just houses all of the user's home directories and Linux brew, homebrew, if that's where you want to put it. That's where I like to have it. And then on back to the root directory, or what I call bedrock, the slash directory is this directory here, where all these things, this is your deep file system. I've heard it referred to as various things, and I liked when I heard your deep file system, because most Linux users have no reason to go behind this directory here, which is the user's home directory. It is indicated by the user's name. You know, you don't often have any real good reason to go behind this unless you're tinkering with the system. And so this is the slash directory, the root directory, the bedrock root directory, which you can see also has a directory called root. This sucks. I hate this word redundancy and this word confusion that happens a couple different times. So at any rate, what they're talking about here, and I apologize if I keep diverting, but I actually think these little diversions are necessary. Again, these videos are people that know less than me, not the rest of the computer world, that they all probably know more than me, but then there's the big, broad rest of the world, which outnumbers all of us, and, you know, this is for them, you know, people that don't know this stuff already. And sudo make install, prefix equals /usr/local. If you want to make these tools that we're going to build globally available to all users, meaning if we put it in, so it's going to install it in USR local, and after make runs it, if you add the install command and then add that prefix for location, the location is /usr for Unix system resources, and then it's going to be, local, and it's going to put stuff right in this area. And you don't ever need to be going messing around. I don't even go messing around a lot in these places. But just so you know, that's where it's going to put it if you do make install. If you add the install keyword, this is what it's doing. Because when it goes into your deeper system, your deep file system, they're global things, events, functionalities, installs, which generally speaking, I have apt or Nala take care of that. Apt and Nala, those package managers, they take care of anything for me back here into this deep file system. Then one step up from that where I don't need permissions, that's where I use Brew. Brew handles package management at the user level, not at the deeper system level. Back here in my world, this is for apt and Nala. Then from here on forward is Brew. There's some other really cool ones like Nix is next level, but that's way beyond the scope of all this. I know I'm diverting a lot, but I really, this time, I think it's necessary to just understand and see what I mean by all this stuff. So finally, to the main event. Enough joking around. To the main event here, we need to make sure we're in the right directory. You know, we're in the cloned repo. We're in here. There's a Makefile in the directory we're in. If you run make in a directory where there's no Makefile, you know, not a lot's going to happen for you. Some flags and with some tools, if you do 0 or a negative number, then it auto defaults to some number or to some detection. I don't think that's how make works. I think you can get a lot of errors or unpredictable things. And if you ran J without a number, I think it can overload or crash your system. I'm not going to find out because I think it might run unlimited jobs or something if you use J without a number. So you don't, if you use the J flag, I'm pretty sure, someone can correct me on this, I'm pretty sure if you run the J flag, you want to specify a number and you don't want to get crazy with this number. And if I'm wrong, it's because I'm guessing and I've never had the courage to find out. I've always ever run the J flag with a 4 or an 8, and I do believe that you can run it with, I think it's nproc for n processes, I think is what this might stand for. It'll auto detect the number of processes that your system can handle. And I'm probably going to say that you need that $sign in there. At any rate, we don't need all that. I don't want to run this command, at least not the way it is. You're going into the deep file system, sudo privileges. I don't want to install this globally. Personally, I don't want to. You probably want to, and so go ahead and do that. So what this does technically, I believe, sudo make install prefix /usr/local, and then this implies /bin. Wherever you make this prefix to, it's gonna assume that there's a bin directory in there, and probably if there's not, it's going to make one. And so where I want to put mine, I don't need to use sudo privileges to go in at the user level. I can do make install prefix, the tilde for path expansion, .local, and that's all I need to put because I already have a bin there. This can take a little while. Still going. And so we're finally done. It took about 10 minutes. Let's take a look at what that accomplished. So after running the make, we got this directory. Oh, and there's, if you look more into make and into building with C or C++, but in this case, I think C, you'll understand what all that is. So if we go into Ranger, you know, this cosmos.cosmos.cc directory is new. You can, if you want to, you can look further into that. This directory is new, and inside of it, the Llama CPP, Llamafile, the local score was built, the stable diffusion, some third-party stuff, temp folder, the Whisper stuff. Let's head out and see if we had anything installed on our system. We go up to .local bin. Now we see in storage and cold storage, these are all the old tools that I had built, however long ago it was. And then just running the make install command. And again, I didn't install these things globally. I did them locally, and I have installed on this system now Llamafile. This is not a .Llamafile. This is just the command, an executable command. As you can tell, it's only 15.2 megs. You have to run the -m. You have to run the M flag and specify the path and location of a model, a GGUF model. Because again, this does inference in C as opposed to Python and using GGUF models because it's just faster. This allows for us to run these things, run inference on models, on LLMs LLMs on CPU. And yes, you can still do it on your GPUs, but it allows for the inference to happen fast enough that you can run it on low-powered hardware. So we have the Llamafile, the bench, which is benchmarking, convert, which this is a shell script, and this converts the GGUF weights. So this is probably just a tool to help build an actual .Llamafile, and it's probably implied through some other command. I can't remember, but I'll have to remember because in an upcoming video we're going to build a .Llamafile. The I matrix, we'll go over what all this stuff means: perplexity, quantize, tokenize, the upgrade engine, Llamafiler. This is just, I think this is just for the V2 server. Lava quantize for quantizing lava models, you know, multimodal stuff. Local score is new. That's for scoring with different metrics. Basically, local score, if I understand it correctly, it allows for some sort of standardized benchmarking for various systems, whoever pools their information on with local score. It sounds like I'm going to start doing it because it sounds like a super useful thing, not just for me, but for the community. And in open source, helping the community is helping yourself. That's kind of what I really like about it. The SD file, you know, that's stable diffusion, the Whisper file, and the zip align. These are all new builds of things that I had previously. With these things, you know, I could go ahead and delete those. And then we want to go in and see if we got new man pages. So where we had renamed our man to a backup, it built us a whole new one. And these are just, you know, when you type -h or run man on it for the manual pages, you know, that's what these files are for, and it built those again. I don't see one for local score though. I figured there would have been a man page for local score because I was interested in looking at that actually. So I wonder what I got to do to get that. And if I figure it out, if it's something I got to download, whatever, not a big deal. But I would like to have that because that's, as much as I don't like reading man pages, sometimes just where you learn everything. Even if you can't understand it, and believe me, sometimes I can't understand what someone's trying to get across to me in a man page, and right to ChatGPT or a Llamafile, I go with it. You know what I mean? And as these Llamafiles keep getting better, I'm using ChatGPT a lot less. Oh my God. The more powerful this local stuff gets, the less reason you have to go online. You know, we've probably been here for 4 or 5 days doing this now, right? But we have everything right in here in .localbin. We cloned down the source code directory, and inside that an AI related inference, really. I guess I should have put AI inference on that. I probably will. And then in here, again, these are the commands that I ran, and I probably should have run the J8 in this command because this is the real command. Run make all you want if you don't install it anywhere. You know what I mean? You're not really doing anything. I was just kind of wanting to see if it would fail out with the J8. And then when I ran make install without the J flag, it took 10 minutes at least, I think, to build everything. So at any rate, I didn't run sudo because I was installing locally, not globally. And for the prefix, the path expansion, the tilde just means the user's home directory that I'm currently logged in as, and .local, and that it infers the bin directory. So that's building this thing, right? Took a 10 or 15 minute project and turned it into a week. But I just wanted to get a couple things across because I remember the first time that I was ever building anything, and it just sucked. The experience wasn't fun. And these things should be fun. You know, the experience wasn't fun at all because typing and using the make command, it's like pressing a button. I don't know what's happening by pressing this button, you know, and I hate that feeling. And I'm sure that there's at least a few of you out there that feel the same. And so just giving you background and context on what's happening with the make command. What in the world are you doing when you're running it on your system? You don't want to have something to potentially break. And if you get a little background and context on the make command, if for some reason then you feel like it's going to break something on your system, you know not to follow along. You know, I feel like they're important things to know. So, and then where I installed it, instead of going into the deep file system, you know, you don't need to run sudo. You don't need to have sudo permissions to do that. And now we have those things on the system, and we can call them up, you know, because they're in a bin directory in Ubuntu. .localbin is automatically inserted into your path because of your .profile here. Simple conditional in your .profile here. This comes preloaded with Ubuntu, by the way. And Debian and other things, you might have to just quickly build this .profile if you want to have the same functionality. It's not hard. You just copy and paste this into a .profile if you don't have one, if you're not using some other things that obviate or override a .profile. But you can put these things in anywhere. This technically could go in your bash RC. All this stuff right here could go in your bash RC if you wanted it to. And it'll do the same thing. Going up to that .local bin again, we have all these newly built and at least one new. The, where'd it go? Local score. At least one new tool. I hope I didn't take something fun and turn it into something grueling for you. I would like to think that I did the exact opposite. I took something that could potentially be stressful and nerve-wracking if you don't exactly know what you're doing, doing, and I made it fun. I hope. Probably not, but I hope. So we'll see you in the next one.